Hi guys, welcome back again. It's Uncle Sam online tutorial and we are here again to discuss concepts related to logarithm. We started off discussing about logarithm on Friday last week, and on Monday we solved a bit of problems related to logarithm. So we are still continuing that to make sure that you have a solid understanding about the different techniques that they use in solving indices problem, which lies on the basic laws of logarithm. That's what we're exploring, because my approach to learning is quite simple. Through my days of doing some live tutorials on TikTok, I've been able to compress three basic models that I use in learning anything, and that's very important to me. The number one rule is understanding the concept. Whatever thing you want to learn, make sure you have a clear understanding, a mental picture of what it is that you are learning. Once you spend so much time, this is where you're supposed to spend majority of the time, to make sure that you have a clear picture of what you are diving into. And afterward, the next thing to do is to learn the different techniques that are used in solving problems under that given concept or topic. And then the last step is what? Practice. Each time you practice, making sure that you diversify. You don't just solve similar problem, but go out of the box. Think outside the box and solve problems that are in different fields within that particular topic that you cover. And with that, you have a solid understanding of that given concept. Anytime you're waking up, even when you're sleeping, you'll still be able to give a concise explanation of what the concept is all about. And so that is the goal of my teaching here, and I'm sure it's going to help you. So for today's class, we're going to be looking into simplification of logarithm, more questions, and the different techniques that we use in simplifying logarithm, which all hangs on the laws of logarithm. Remember, the basic idea of logarithm, I always like to make sure that I give you a clear picture before we proceed. If you have log b base a is equals to c, this is an expression that shows logarithm of a number. And I say that the logarithm of a number, which is referred to b is the number or value, a is the base, and c is the power. So this thing that you see here summarizes the whole idea of logarithm, which is to tell us that the logarithm of a number b to a given base is just telling us the power, which is c, that the base a has to be raised to give us what? The value of this b. So b is basically what? The base raised to what? The power of c. That is the basic idea behind the logarithm. So that is what we are here to discuss. So in simplification of logarithm, I just wanted to make sure that you have the basic laws of logarithm. That is what we're going to be employing in solving problems under what? Logarithm. So look at this basic example. First, evaluate log 0.0001 base 10. On Monday, we treated the basic simplification of logarithm, which had to do with whole number values. Now we're diving into what? Decimal numbers, and it's still the same process. One of the things that will help you in solving this kind of logarithm simplification very well is if you have the knowledge of indices. That is why I started off with discussing about indices, which you can find on my page. If you go to my YouTube channel, you'll see where I did a concise explanation of what logarithm. And if you find this video very interesting, please give me a subscribe to this YouTube channel, because it's going to be very interesting moving forward. So if I have this kind of expression, that means evaluate log 0.0001 base 10. Now, the first thing I need to do here is, since I know that the basic idea of logarithm is that the logarithm of a given number to a given base tells us is looking for the power that the base has to be raised to give us this logarithm. That is the basic idea. And so the first process I will employ in simplifying this particular expression is to find another way to represent this 0.0001. Yes. And it turns out that normally if I have 0.0001, first I can first of all try to change it, employing my knowledge of fraction. That is what I'm going to be employing here. to change this to become a fraction, which is same thing as what? The point becomes 1, that's the traditional way. And how many numbers you have here becomes the number of zeros. So it's going to be 0, 0, 0, 0, 4 zeros, because after the decimal point you have 4 values. So this becomes 1 over what? 10,000. So that is to say that 0.0001 is same thing as what? 1 over 10,000. Now we're not done yet, because this particular value is not going to so much help us in analyzing this particular problem. We need to first of all step it a little bit down, find a way to break it down a bit. And it turns out that according to the law of indices, if I have a to the power of minus 1, it's still the same thing as what? 1 over a. So if that is the case, I can reverse this process, since I already have 1 over, which is reciprocal of 10,000 here. I can rearrange it to be 10,000 raised to the power of negative 1. So this is simple as saying 10,000 raised to the power of what? Negative 1. Now, this is now something I can work with. So with this in mind, I can simply go over here and replace the 0.0001 to the what? 10,000 raised to the power of negative 1. Now I can now go on and solve without any fear. So solution. This becomes the log of 10,000 raised to the power of negative 1, which is what I've replaced this to be. This and this, they basically mean the same thing. To the base of what? 10. So I've done the major work, which is changing this to become this. Now, the next step is to simplify this 10,000 here. Yes, I know that 10 times 10 times 10 times 10 is what is going to give me what? 10,000. But according to indices, I can represent this, because it's still the same number multiplying itself successively. This can equally be represented as just 10, and then how many times did the 10 multiply itself? 1, 2, 3, and 4 raised to the power of 4. That will still give me what? 10,000. So what am I trying to achieve? Well, I'm trying to find a way to simplify, because the goal of our class today is simplification, so that once I've simplified it, I'll be able to apply each of the law, or 1 or 2 laws of the laws of indices, and then we move on. So what am I going to do here? Next thing I'm going to do here is to replace this 10,000 here with 10 raised to the power of 4. That is one way to do it. So if I go on and do that, this becomes log 10 raised to the power of 4, bearing in mind there is still an outermost power here, which is what? Negative 1 to the base of 10. It's getting quite interesting. So I can still employ one of the basic laws of indices, which is what? The law of what? Power. When you have a power that is inside the bracket and one that is outside the bracket, they go on to multiply themselves. So with that in mind, this power here and this power here will multiply themselves, so that this becomes log of 10 to the power of 4 multiply negative 1 will give us negative 4, then to the base of 10. And then at this point, it's looking now interesting. It's looking very, very fascinating. I've got it at an angle that I want, so that I can now go on and then apply one of the laws of what? Logarithm. We state that is the power law. If I have log b raised to the power of n to the base of a, it's simple. This is same thing as taking the power and multiplying to the log. So this is same thing as what? Any log b base a. This is what it simply is. So I can go on and apply this law here. So I'll push the power, which is negative 4, at the back of the log. So it becomes negative 4 log 10 base 10. It's quite simple. Alrighty. Well, it's quite easy to solve this question, but one thing is missing here, because based on the analogy that I gave, according to the laws of logarithm, to find a logarithm of a number, there must be the number and there must be the base, and then you're looking for the power. That is the basic ideology behind logarithm. But if you look over here, for these two expressions here, both the numerator and the denominator, we are just having the log of square root of 5, and here the log of 5. We're not having a base. Now, I mentioned this in the last live session that I had on Monday, that anytime you see a logarithm that does not have a given base, what you need to know is that by default, because the base 10 system is what we basically use in. So anytime you see a logarithm expression without a given base, just know that by default it is written in what base 10. So your choice is either you decide to make it visible or you would continue walking along with it just the way it is and do your normal simplification. So anyone you choose works in this case. So in this case, I want to make the base to come alive. So solution, this becomes, I'm going to divide this into two so I can have enough space to naturally do some solving. So this is something log square root of 5 base 10. Like I said, the base, anytime the base is not given, by default, there is a base of 10 there. All over what? Log 5 to the base of 10. So what can I do here? Well, this is quite easy because I'm almost done with this particular expression. Square root is same thing as what? Power of half. Cube root is same thing as what? Power of what? 1/3. Fourth root is same thing as what? Power of 1/4. So this is what I simply mean. I can rearrange this square root to be what? The log of what? 5 raised to the power of 1/2 base 10. Everything here divided by what? The log of 5 base what? 10. So I've represented this square root to have represented in another form because square root is same thing as what? A power of what? Half. Now that I've done that, I'll simply take this word power according to one of the laws of indices. If the log has a power, it's okay. It's according to the rule of logarithm that I can take the power and put in front of the log. So this now becomes, when we continue here, and let me clean up here so that I can continue. I'm done with this. So it's very okay to actually replace this to now become 1/2, replacing the word, the power, because it's one of the laws of what? Logarithm. 1/2 log 5 base 10, all over what? Log 5 base 10. So simply put, the square root switched off to become half, because square root and power of half simply mean the same thing. And then according to the laws of what? Logarithm, you can take what? The power and multiply the log. You can simply do that. So it becomes 1/2 log 5 base 10. Now at this point, what can you notice? Well, if you're very observant, what you notice is that both the numerator and the denominator mean the same thing, or they are the same. So because there is a division that is what? Separating them, they can simply what? Go and what? Cancel each other. And if they cancel each other, you're just left with what? 1/2. You actually simplify this expression. That's all that is needed. So when you know these rules, it becomes very easy for you to apply it once you see something similar. And that is why I'm bringing different scenarios or different type of question, because that is the model that I use. Have a basic understanding of what? The concept. Have it, be able to visualize the concept. That's why I keep talking about it, even in the midst of my solution, so that you have a good understanding. You know that it all boils down to the concept, not the techniques. The techniques can always be learned, but the reason why most people don't really value all these things is because they don't have a pictorial reference. Our brain is designed to work with pictures. That's why visuals are very engaging. Yes, visuals are designed, our brain is designed for that. So a very good way to maximize this is to make sure that anything at all is you're learning, whether it's maths, whether it's science, whether it's anything at all that you find yourself learning at any given point, one thing you need to know is that first, the major work is you trying to make sure that you have a mental picture or good understanding of what that concept or topic or whatever thing that you are learning. Because that makes it much easier for your brain to flow with it and not see it as a route method of what? Learning. So once you visualize it, then you learn the techniques that what? Pertain in solving problems under that particular concept or topic. And then you practice. Each time diversifying. And that is simply what we have been doing here for a while. So the next phase now is to solve some other problem that might, at first seem off, but it's quite simple. So let's go on and solve that particular question. So you see how we can, first of all, we know the idea, the basic idea of what logarithm wants to pass across to us. So look at the question. Sometimes it does not come plainly whether Sometimes it's a bit confusing on what you're supposed to do. But one thing that you need to do and you need to know is for anything that looks complex, it is still made of what? Simple steps that accumulated to give it that complex what expression that you see. So it's always good to what? Do the bit, do it bit by bit. So the first thing that we're going to be looking at here is this simplification problem. Simplify 16 raised to the power of 3 over 2 plus log 0.0001 base 10, then plus log 32 base 2. This is what we have. Now, this might seem a bit complex because, come on, there is no log here. Well, the problem is the equation is simplified. So if there is no log, we can still go ahead and simplify. Nothing stops us from doing that. And so to do that, what do we simply do? Well, what we can do here is, first of all, I can decide there are different routes of solving this equation or simplifying this particular expression here, the first part here. There are different ways I could simplify them. One of the ways I could do that is to switch up 16 to now become 4 squared. So it becomes 4 squared, then raised to the power of 4, 3 over 2. Then plus log. Based on the previous example that we saw, we've learned that 0.0001 is something as what? 1 over 10,000. And 1 over 10,000 is something as what? 10,000 raised to the power of what? Negative 1. And 10,000 raised to the power of negative 1 is something as what? 10 raised to the power of minus 4. This is it. This is the process that transforms this to this and then transform this to this. So it's something as what? 10 raised to the power of negative 4. So I can what? Simply replace the 0.0001 to 10 raised to the power of what? 4. So this is something as what? Log 10 raised to the power of minus 4 is 10, then plus 32. Is there a way I can reduce 32 to the base raised to something base raised to a power? Yes, because it turns out that 2 raised to the power of 5, which is 2 times 2 times 2 times 2 times 2, will give me what? 32. So this is something that's saying log 2 raised to the power of 5 base what? 2. Now, I've done some basic simplification because, like I said, every complex thing you see out there, your ability for you to decode it is what makes you good at it. It's what makes it that you actually have a solid understanding, not that you have a shallow understanding of the concept. So whatever thing you do, one thing you must know is learn simplification. That is what maths teaches you, and that is what I'm here to bring across to you in this live section. So first, I simplify 16 to now be 4 squared, and there's a reason for that. Then I simplify 0.0001 to now become, this is a process where it transforms from 1 over 10,000 to 10,000 raised to the power of minus 1, and then to 10,000 raised to the power of 10 raised to the power of negative 4. That is what it is here. And then I switch up 32 to now become 2 raised to the power of what? 5. Now that we've done this now, we can go on and simplify each. It's quite easy to do that. So how do you simplify it? Well, based on this part now, according to the law of indices, where you have two powers, one inside the bracket and one outside, the inside will go on and multiply. So they multiply themselves. So this is simple as saying 4 raised to the power of 2 times 3 over 2. Then plus, according to the laws of logarithm, if the log has a power, it's okay to take the power and what? Put it as a coefficient of the log. So this is something as what? Open bracket. There's a reason for opening bracket because there's this power here has a negative sign, so I don't confuse one for the other. So negative 4 log 10 is 10. Then plus, the same thing will happen here. The power here will come and become the coefficient of the log. 5 log 2 is what? 2. This is what I have at this point. So we'll go on and still simplify the individual 10. 2 here will go on and cancel this 10. So that what I have remaining here is 4 raised to the power of 3. 4 to the power of 3. Then positive multiplying negative will give us what? Negative. And then you have here negative 4. And then any log to its base, any log that has the same value as its base is equal to the 1, according to the laws of what? Logarithm. So this sentence minus 4 times 1, then plus, same thing here. Any log to its base is equal to 1, so it becomes 5 times 1. So that's what you have here. And then 4 raised to the power of 3 is going to give us what? 64. Because if you are still treating what simplification is in the process. Then minus 4 times 1 is 4. Then plus what? 5. So 64 minus 4 will give us what? 60. And 60 plus 5 is going to give us what? 65. This is what you have. We have successfully what? Simplified this given expression. And isn't it interesting? Isn't it? Brilliant, brilliant, brilliant. Brilliant. So I have some other questions for us to examine here, just to gain better understanding. Remember, after today's class, we're going into the aspects of logarithm. So I'm going to clean it here. Please take a shot if you may. I'm going to clean it in 5, 4, 3, 2, and 1. Everything is simplification. You look at it, you look at the best possible way you could have solved this, and you go ahead and solve it that way. So let me try this question with you all. Evaluate log 0. Log 0.04. Log 0.04 divided by log 18 base 3 minus log 2 base 3. So this is what we have here. So let's go ahead and solve this particular problem together. How do we go about solving it? Oh, by the way, this is log 0.05, log 0.04 base 5. So the way we can go about solving this problem is, it's not just by looking at it and cracking your brain, oh, I don't know this. No, you try to do the basic things that you can do, and that is what? Employing the laws of logarithm into the given expression. But before that, remember, this is a decimal number, and so we need to find a way to express this in a format that we are used to. So we know that 0.04 is same thing as what? This point becomes 1. This is the traditional way of changing from decimal to fraction. And then how many numbers you have after the decimal point determine the amount of 0 you're going to add here. The decimal point is same thing as 1. So this now becomes 4 over what? 100. Which, if I reduce, use 4 to divide, 4 divided itself 1, 4 divided 100 will give us what? 25. So 0.04 is same thing as 1 over 25. That's one of the first things I'm going to do here. In my quest to simplify the expression. So this becomes log 1 over 25 base 5 all over log. See what I'm going to do for the denominator. Since I know that under the basic laws of logarithm, subtraction simply means division of the logs, provided that the two logs or the two terms have the same base. And here, both of them have the same base. So pick one of the base, which is the base of 3, and then divide their logs, which is 18 over 2. We're just getting started with the simplification. So once I've done this now, this is now going to give us log, I'll just leave this as same thing as log 1 over 25 base 5 divided by what? Log 9 base what? 3. This is what I have at this point. Well, I could still do something to this 1 over 25. What could I do? Well, I know that 25 or 1 over 25 is same thing as what? 25 raised to the power of what? Minus 1. According to the law of logarithm, that has to do with what? Inverse or reciprocal. So that is a particular thing that we're going to be doing here. So we replace this to become log 25 raised to the power of negative 1 base 5 divided by what? Log 9 base 3. Sorry, log 9 base 3. This is what we have here. And then I can simply what? Change this 25 to become 5 squared, because 5 squared is going to now become 5 squared, then raised to the power of what? Negative 1. Which the power inside can go on and multiply according to the law of what? Indices, that if you have two powers, one inside and one outside, I can go and multiply them. So this statement is saying 5 raised to the power of 2 times negative 1 will give us negative 2. So I can go on and switch up this 25 raised to the power of minus 1, which I've simplified here, to now become 5 raised to the power of what? Minus 2, basically meaning the same thing. So once I've done that, I'll come over here and that this becomes the log of 5 raised to the power of minus 2, which is the simplified version of what? 1 over 25. Then to the base of 5 divided by what? Now, I can now do something to this 9 because since it's having a base of 3, I can replace this 9 to now become 3 squared because 3 squared is the same thing as what? 9. So this becomes log 3 squared base what? 3. So we're now expressing it in terms of what? A base and a power. And it's it's purposeful. There's a reason why we are doing that. So at this point now, what are we going to do? Well, according to the laws of logarithm, if the log has a power, it can go and become the coefficient of the log. So that's what is going to happen here. So this now becomes negative 2 log 5 base 5. We push the power to become the coefficient of the log. So that's what we're doing here. Same thing here. This becomes 2 log 3 base 3. This is what we have. And so what is the next line of action to perform here? Well, still according to the laws of what? Logarithm. If I have a log that has the same value as the base, it still equals to 1. So this is simply as saying negative 2 here multiplied to the summary of this log 5 base 5, which is equals to 1. All over, the same thing happens here. 2 multiplied to 1. And that's going to give us negative 2 over 2. And if you divide that, it's going to give us what? Negative 1. So the simplified version of this expression, after I've evaluated it together, gave us minus 1 as our what? Final answer. I hope this makes sense. So I have about 2 more questions to discuss here, and then we move on. We end today's class, and I introduce something very interesting before that we'll be talking about later in the next class. So take a screenshot, guys. Take a screenshot, and if you have any question at any point, please leave it in the comment section, and I will attend to you. So let's go. I'm going to clean it up now so that we can go on to the next question. Okay. So what next am I gonna do? Well, let's solve this problem together. Simplify log 7 minus log 3 divided by log 3 minus log 7. This one is quite interesting. But we're going to do it together. Trust me. So how about doing this or solving this particular problem? Well, I'm going to show you the wrong method, and then I'm going to show you the right method. I think that's clear. So what is the wrong method of solving this problem here? Well, one of the ways that people, like personally, before now, I will have used in solving this problem, is just to employ the basic law of logarithm. And the basic mindset that you should have, that when you have a log without a base, it simply means that each of them have a base of 10, which you can decide to make visible, or you can decide to keep it invincible. In this case, I don't want it to become visible, so it's going to be the way it is. So if we continue now, this is going to give us that log, since it's negative, it simply means division. So log of 7 over what? 3, because since they have what? An invisible base of 10, okay? Divided by what? Log of what? 3 over 7. This is what we have here. And then we can do something here. Because since we're having division here, we can actually make, since the logs are the same. Since the logs are the same, this is one of the, remember we're observing the wrong way of solving this problem. This is actually a wrong way of solving it. By taking, let's say, since the log is common, we pick one of the log, and then we now say 7 over 3 divided by what? 3 over 7. Seriously? This is wrong. Do you know the reason? Because what I simply did here, I took one of the log, and then I now put division. This is wrong because this does not align with the basic law of logarithm. Logarithm does not have a law that states or talks about division. It does not. So anytime you're performing a division operation, you are performing a form of simplification. It is not tabled down in the law of what? Logarithm. Because in log of logarithm, if you have log a base b minus log what? C base b. This is where you can now pick one of the logs, which is one of the base, which is b. It becomes log to the base of b, and then you divide this, the log a, by what? C. This is a over c. You can now apply it here where you already have log 7 over 3 over. You cannot pick one of the log and then do the division. It's wrong. So then, what is the right approach to solving this problem? Stick with me here, guys. Stick with me, stick with me, stick with me. So the right approach to solving this problem is this. Still the same approach. Remember, base 10 is here, okay? So I don't want to make it visible. So the same thing as well, subtraction. Well, according to laws of indices, of law of logarithm, subtraction is part of the laws of what? Logarithm. So I can actually what? Employ that, which is what I did earlier. The log of what? Pick one of the logs and then divide the 7 by 3. This is what subtraction law of logarithm talks about. You simply what? Divide the logs, provided I have the same base. And in this case, since there's no base given by default, it is what? In base 10. So once we have done that, it's now going to be divided by log. Do the same thing. The bases are the same, so you divide 3 by 7. So it's log 3 over 7. Now look at what I'm going to be doing here. Very, very interesting. I'm going to introduce something that is quite interesting, and that is why I love math so much. So this is something that's saying log 7 over 3 divided by log 7 over 3. Wait a minute, this is 3 over 7. Why am I now changing it to 7 over 3? Turns out that I can do that provided that I attach a power of -1 there. Which is to say that if I have 7 over 3 raised to the power of -1, each of them will share the power. If I use the power to multiply each of the expression here, it becomes 7 raised to the power of what? -1 all over 3 raised to the power of what? -1. And this is same thing as 7 raised to the power of -1, it means inverse. Anything that raised to the power of negative is same thing as inverse. That is 1 over 7, then all over what? 1 over 3. Which is same thing as what? 1 over 7. This division changes to multiplication, and then you invert this fraction, becomes 3 over what? 1. And that will give us 3 over 7. So this 7 over 3, all raised to the power of -1, is still the same thing as what? 3 over 7. But there's a reason why I had to employ it here. So that I can find something, the log that is common, and be able to cancel some things out. So this is what I'm doing here. So at this point now, what are we going to do? Well, I can apply the law of power for logarithm. That is, take the power and what? Let it become the coefficient of the log. So this now becomes the log 7 over 3 all over -1 log 7 over 3. So I've taken the power here and it becomes the coefficient of the log here. So at this point now, you see that log 7 over 3 is common on both the numerator and denominator, and so I can cancel out. So what is remaining here is coefficient of this is +1, so it becomes 1 over -1, and that will give you -1. So the first approach was actually very wrong. We couldn't have done it with that first approach because there is no avenue for us to employ division under logarithm. There is no avenue for us to do that. So at this point, our answer is -1. So this is to tell you that you can actually bring in something. It's not enough to just know that 1 over 2. Maybe when you're exploring fraction, it's okay to leave this as 1 over 2. But when you're exploring indices and logarithm or different other topics in math, you just know that this 1 over 2 is same thing as 2 raised to the power of -1. So someone that knows just that 1 over 2 is 1 over 2 or half, and someone that knows that 1 over 2 can also be raised or expressed as 2 raised to the power of -1, that person has more tools in this toolkit, because at any point in time, based on demand, they can switch up this expression to become this, and it will be logically through. That's the basic idea. So that is it. So I'm going to be solving one more question, and then I will introduce a concept that is quite interesting that I want us to talk about, which is still under these indices. Very, very interesting. I found it out. I didn't know this before now, and I found it. I was so happy when I discovered it. So I hope you're going to be triggered and happy as well when we get to explore it together. So this is it. This is what we're going to be exploring. The last question, which is going to lead us to what we want to discuss. Okay, okay. Now I'm going to clean up here and then we explore it, because this last question is supposed to lead me to the next aspect of this logarithm that I want us to talk about, which is this. Simplify log 32 base 0.25. Simplify log 32 base 0.25. Well, well, this is what I mentioned earlier when I was talking about the model of learning that I employ. These kind of expressions, if you're able to understand it, based on our brain's neuroplasticity, it adds more, more things to your brain, and you are better off by doing that. And that is why I like bringing in different scenarios or different questions so that you have better understanding and gain root, not just the basic. You see how other laws of logarithm can be employed in some other aspects. So how do we go about solving this? Any idea? Well, I have a bit of problem here, if you ask. I'm having a base of a decimal, and that's not really what I want. Now, is there provision to remedy this? Yes. There, because in logarithm there is actually a provision where you can actually do what is known as change of base, which is one of the laws of logarithm that I taught when I discussed it on Friday last week. Please, you can go to my profile on my YouTube account or profile. You'll see the video I did on introduction to logarithm. There I explained all the basic laws of logarithm in detail. So you can go there and watch the video so you have a better understanding. So what do I do at this particular point in time? I can employ change of base. And how do you employ change of base in indices? Or in logarithm, sorry. So this particular expression, the log can become, or the log becomes the, how do I put it there? How do I put it? For change of base system, the log becomes the numerator and the base becomes what? The denominator. That is to say that this can be expressed as log of 32 to a given base that we want, minus, it's not division, it's minus what? Log of what? 0.25 to the new base that we brought into play. But before we go into that, there's something I just remember that is quite important. In as much as the base here looks like something that is not like what I used to have, normally we have whole number values and not decimal, there's still something that I can do to this base to simplify it, because everything we're talking about today falls on what? Simplification or evaluation. So this can also be represented as log 32. 0.25 is same thing as what? 25 over 100, which if you reduce is same thing as 1 over 4, which is if you reduce is same thing as 4 raised to the power of what? Minus 1, which if you reduce is still the same thing as what? 2 raised to the power of minus 2. So from here to here to here to here, this is what you have. So this is something as saying what? Log of 32 base what? 2 raised to the power of minus 2. Wait! Is the base allowed to have a power? Turns out, yes, it's allowed to have a power. And after going through the normal route to solve this, which is the change of base system, I'll show you a shortcut on how to go about solving this, because this is going to lead us to the next aspect of this logarithm class. So let's get on with it. So because there is something that is happening here that I don't really like, I can decide to employ change of base. And so it's just as simple as saying putting both in what? Base 2. So I want to put both the log and the base originally to be in base 2. And by doing that, I separate it. It now becomes log of 32 base 2. And then because this is the log, this is the base, to apply change of base system, this is what I wanted to do. And let me paint it in such a way that it's very, very easy for you to grasp. So apply change of base system, the log comes first, and then it's going to be minus the value of the word, the base, that is now a new log to a new base. So it's simply as saying log 32 base 2 minus log 2 raised to the power of minus 2, which was originally what the base, but is now a log because we are applying a change of base system. Now to the base of what? 2, because we say putting both in what? Base 2. Now this is what we have at this point, and it's very, very interesting. This is a solid and logical word. It's a proven law, so it's very, very okay for us to apply this rule. So the next thing to do now is to simplify. Yes, we can go on to simplify. And to do that is quite easy. We can replace this 32 to be 2 raised to the power of 5. So it becomes log 2 raised to the power of 5 base 2 minus, this is already in the form that we want it, 2 raised to the power of what? Minus 2 base 2, because we've done the work to reduce it into this. Now we can now go ahead and apply the basic law of logarithm, which is what? The power law, which the power, if the log has a power, it can go and become the coefficient of the log. Same thing will happen. So this is now going to give us 5. In this case, it will now become 5 log 2 base 2, then minus, open another bracket, and then add the power of this other side, or this other term, negative 2 log 2 base 2. Now there's a reason why I usually try to demarcate it, so that I don't get, because sign is one of the things that most people struggle with. But one way that you could remedy for that is make sure that at any point, majorly if you're working with a negative, make sure that you demarcate it. Separate it by putting a bracket so that this is for this particular section. And that's what I simply did here. Because the power here is negative 2, I put a bracket to actually show that it's negative 2, so that when this negative and this word negative come in contact, they operate on each other, and then we'll have what? A positive value. So this is similar saying 5 log 2 base 2. Then negative multiply negative, this is the whole point of me putting the bracket so that they can be able to work on each other, the two signs here. Negative multiply negative will now give us positive log 2 base 2. This is what we have at this particular point in time. So at this point now, what do you think we're supposed to do? Well, it's quite easy. The log of anything into its base is equals to 1. So this is simply saying 5 multiplied to 1 plus, sorry, there's a 2 plus 2 multiplied to 1, and that's going to give us 5 plus 2, and that's going to give us equal to 7. Quite interesting, right? That is what we have here. That's the answer. And now this is the concept of change of base, where if you change a base, the original log is not going to be minusing the base. That's what we did here. And we attach what? A new base, because we say in what? In a new base, which is base 2. Now, one final thing. Another way, one final thing that I want to talk about, which I want you at the end of this class, once I talk about it, you can employ that and solve this particular problem. So I'm going to leave the problem here and talk about the final rule, which is what I love. One of the major rules that I discovered that will help us in solving this way faster than change of base. So if I have an expression log a raised to the power of n base b, where b is equals to a raised to the power of 1 over n, we are going to simplify this expression. This will help you to stretch your brain a little bit so that you have better understanding of this. But the first thing I want to do before I go into this is to tell you that when you have an expression, let's say log a base b raised to the power of n, the same way that log a raised to the power of n base b is equal to you taking the power of what? The log, and then it becomes power. Shortcut to it, this thing that we did in solving this problem, shortcut to it is to tell you that this is the same thing as what? 1 over n. Why 1 over n? Well, since if the log is the one that has the power, it becomes the log directly multiplying the power, directly multiplying the log. But if it's not the base that has the power, it's the same thing as what? The reciprocal of the power of the base. Multiply to what? The log of what? Base what? B. This is the summary. And I want you to use that to see if you can be able to solve this question once you have simplified it. That's the assignment for today. So, but let's use this last question here to finish up. So, we have log a raised to the power of n base b and we're asked to simplify where b is equal to a raised to the power of 1 over n. So how do we go about solving it? I'm going to solve it the extended step so you see it. So this is saying log of a raised to the power of n, then replacing b with a raised to the power of what? 1 over n. So what do we do here? Remember the shortcut that I told you. Since if the log has a power, it simply